So here's the notes for 4.3 and 4.4. We are solving quadratic equations. So we're going to be using the idea of factoring and use that to solve quadratic equations. Now, you're going to hear me use a lot of different vocabulary words that mean the same. So like solutions. When we solve for our variable, we will get our solutions. But some other words that you'll also hear is that they're called roots, and they're also called zeros. So I will be using kind of those interchangeably throughout this probably lesson. So as long as you know solutions, roots, and zeros, they mean the same thing. So that just means that you solve for x. Now, in order to use factoring to solve, here's our steps we're going to follow. Factor the quadratic. So we've done this. So we did it when a equaled 1 and when a did not equal 1. So we're going to have a combination of those. We're going to set each factor equal to 0 and then solve each equation for the variable. So let's go ahead and let's do that with these problems. Okay, example 1, we have m squared minus 6m equals 0. Now remember, the first thing you should always ask yourself is, do these terms have something in common? This is our greatest common factor. If I look at these two terms, they do have something in common. They both have an m in common. So I'm going to go ahead and take that out and rewrite my expression using one set of parentheses. So when I take an m out of m squared, I'm just left with m. And when I take an m out of negative 6m, I'm just left with negative 6. Okay? Now notice what is left inside the parentheses. I can't factor this anymore. So that means I'm done factoring, and I'm going to set each of these factors equal to 0. So remember, don't forget to always bring down your 0 because we are solving. So let me kind of just say these are what we call factors. Okay, so remember we talked about that when we were factoring. That's why it's called factoring, because we get factors. Remember, factors are basically terms, phrases, whatever, that multiply. Okay, so now we're going to have m equals 0. So m is a factor. We set that equal to 0. And we do m minus 6 and set that equal to 0. Now for the first one, I can't add, subtract, multiply, divide anything. So m equals 0 is already just our solution. Here, I'm going to add 6 to the other side to get our variable all by itself. So I get m equals 6. So this is another solution we have. So we have two solutions. Or remember the other words we have? So we have two roots, two zeros. Okay, so remember those three words are the same thing: solutions, roots, and zeros. Okay, let's go ahead and try the next one. We have x squared minus 3x minus 18 equals 0. Remember, when we do basically solve, we always want to make sure the equations are set equal to 0. We don't want anything on the other side. So since we have this already set equal to 0, we're good to go. Our next thing is to see if these three terms have anything in common. Well, they don't have a number in common other than 1, and they don't have any variables. So now we go ahead and create do our factoring. Notice our a value is 1, so I can go ahead and do our two sets of parentheses. And we're just going to have x and x. Now remember, I'm trying to figure out all the numbers that multiply to 18. So that's 1 and 18, 2 and 9. We got 3 and 6. So now we need to figure out which pair will add up to a negative 3x. Well, that's going to be our 3 and 6. There we go. So I have 3 and 6. Now notice I have a negative 3, so that means my larger number has to be negative, and then my smaller is going to be positive. So I know 3 minus 6 gives me negative 3. So now that I have my factors, so I have two of them here. These are my factors, as you can tell. I'm going to set them equal to 0 and solve. So I have x plus 3 equals 0, and then x minus 6 equal to 0. Now for both of these, I do need to move the number over to get the variable all by itself. So on the first one, I subtract 3, so I get x equals negative 3. On the other one, I add 6, so I get x equals 6. And so once again, I have two solutions, roots, zeros. Okay, remember those three terms are meaning all the same. Okay, let's go ahead and try the next one. So here I have x squared minus 9 equal to 0. Good that we already have it set equal to 0. If I look at these two terms, they don't have anything in common that I can take out. So now I go ahead and factor. Now notice what this is. We do have a binomial. We're subtracting. And remember, our a and c values, right? They're perfect squares. So this is our difference of squares here. So remember when we do our difference of squares, now since our a value is 1, we can already create our two sets of parentheses, and we already know we can do that because they didn't have anything in common. We set it equal to 0. I have x and x. And remember, for this one, all we have to do is just take the square root of 9, which is 3, and that's going to be the number that is in both of these parentheses. One's going to be minus, one's going to be plus. Okay, so now I set my factors equal to 0. So I have x minus 3 equal to 0 and x plus 3 equal to 0. I solve for my variables. For the first one, I'm going to add 3 to both sides. So that will give me x equals 3. On the other one, I'm going to subtract 3 on both sides, so I get x equals negative 3. So x equals 3 and x equals negative 3, they are my solutions. They are my roots. They are my zeros. Okay, what I would like you guys to do is go ahead and pause the video and try example 4. Okay, let's go ahead and go over this. So here we already have it set equal to 0, so we're good to go. We look at our three terms to see if they have anything in common. They do not. They don't have a variable, and they don't have a number other than 1. So since our a value is 1, I can already automatically create my two sets of parentheses. Make sure it's set equal to 0, and I have y and y. Now let's think of all the numbers that multiply to 64. I have 1 and 64. We'll have 2 and 32. 3 doesn't work, 4 does, so 4 times 16. No 5, no 6, 7, then we have 8 and 8. Well, the pairing that adds up to a positive 16 is going to be 8 and 8. And then since it's a positive 16, both of these are going to be positive. So now I set my factors. Remember, y plus 8 and y plus 8, they're both my factors. I set these equal to 0 and solve for the variable. So I have y plus 8 equal to 0. And same thing over here, y plus 8. Now if you notice, the factors are exactly the same. So that means when we solve for both of our factors, our solutions are going to be the same. So on both of them, I'm going to subtract 8. So I should get y equals negative 8 as my solution. There we go. Okay, let's go ahead and try example 5. Okay, now notice here we do not have our quadratic equation equal to 0. So that is our first step to do. Set this, move things over to make it equal to 0. Now whenever we want to set it equal to 0, we always want to keep our x squared positive, okay? So we're going to set this equal to 0. going to put it down here so we know that's a step. So set equal to 0. And so what I'm going to do, because I want to keep my x squared positive, is I'm going to move the 14x and the negative 49 over. So I'm going to subtract 14x from both sides. Now, 14x and x squared, they are not like terms, so you cannot combine them. Okay? And then my 49, I'm going to do the same thing as well. So here, since it's minus 49, I'm going to add 49 to both sides. So add it to the other side as well. So when I do that, now it's going to be equal to 0. I'm going to rewrite this because I do like having my equation on one side and then the 0 on the other. So I have x squared minus 14x and then plus 49 equal to 0. There we go. Okay, so now it's just like what we do. The first thing is figure out if there's a greatest common factor between these three terms. There is not. Notice my a value in front, which is in front of the x squared, that is 1. So I go ahead and create two sets of parentheses. I can put x and x in both of them. Now we need to figure out numbers that multiply to 49. We got 1 and 49 and 7 and 7. We're going to have to see which one adds up to negative 14x. In this case, it's going to be my 7. So I have 7 and 7. And notice that my 14 is negative, so that means both of these have to be negative. Notice that my factors are exactly the same. So that means when I set both of them equal to 0, my solution is going to be the same. Okay? So I have x minus 7 equals to 0, and x minus 7 equals to 0. On both of them, I add 7 to both sides. So I get x equals 7 and x equals 7. So x equals 7 is my solution, it's my 0, it's my root. There we go. Okay, let's go ahead and do example 6. I would like you guys to go ahead and pause the video and try this one on your own. Okay, let's go ahead and go over this. Notice that this is not set equal to 0, so that's what we need to do here. So we need to set equal to 0. Now my c squared, basically whatever your variable squared is, you always want to keep that positive. It makes factoring so much easier. If not, it's going to become a little bit difficult. So that means I'm going to move the 48 over, and to do that, I'm going to subtract 48 from both sides and subtract it over here. Now I can't combine it with the c squared or the 8c because they are not like terms. So now I have c squared plus 8c equal, or minus 48 equals 0. Now that I've set it equal to 0, my next thing is to see if these three terms have anything in common. They do not. Okay, so now notice also that in front of my c squared, it's the a value is 1. So I can already automatically do my two sets of parentheses. And I have c and c. Okay, now we need to figure out the numbers that multiply to 48. We got 1 and 48, 2 and 24. We do have 3 and 16. We're going to have 4 and 12. This one has a lot. 5 doesn't work. Let's see if 6 does. Yep, 6 times 8, and that should be it. Okay, so now we need to look at the pair that'll add up or subtract to an 8. Well, that's probably going to be our 4 and 12. So So I'm going to have 4 and 12. Now notice that my 8 is positive, so that means 12 has to be positive. My 4 will have to be minus. So if I do 12 minus 4, that gives me my positive 8. So now I'm going to go ahead and set each of my factors equal to 0. So I'm going to do my c minus 4 and my c plus 12. So I add 4 to both sides, so I get c equals 4. And then I subtract 12 on both sides, I get c equals negative 12. So c equals 4 and c equals negative 12, they are my solutions, they're my roots, and they're my zeros. Okay, let's go ahead and go to example 7 here. So I'm going to kind of help you guys out on this one. Because now notice that, right, we have something maybe other than 1. So for the past few problems, our a value has always been 1, so we could just already automatically create 2 sets of parentheses and find the factors of the last. Now also notice between these two that they have something in common. They both have a 5 in common, so that's my greatest common factor. So knowing that my equation is already set equal to 0, I can go ahead and factor out a 5. Now on my first one, when I do that, I do 5 divided by 5. I'm left with x squared. And then my minus 45, when I do that, negative 45 divided by 5, that gives me negative 9. So now here, I'm going to go ahead and factor x squared minus 9. Now, we have already done this, so I'm going to go quickly on this factoring because we already did this problem. So remember, x squared minus 9, that is x minus 3, x plus 3, or you can reverse that. It does not matter. Now, this is the part we need to talk about. So, with this 5, right, remember, we say we set each factor equal to 0. Now, if I set 5 equal to 0, though, is that a true or false statement? It's false, because 5 can't equal to 0. So anytime you do have something that might be on the outside, if it's not a variable, or there's no variable attached to it, you do not need to set it equal to 0. On our first example, when we had an m on the outside, that was a variable, so we set it equal to 0. But since the 5 is just a number and there's no variable attached to it, we do not need to set it equal to 0. So that means all we need to do is to set these, which these are our factors, equal to 0 and solve for x. Now we kind of already know from our previous example, I think it was example number 3, what our solutions are going to be. So we have x minus 3 equal to 0 and x plus 3 equal to 0. So our two solutions, roots, zeros, they are going to be x equals 3 and x equals negative 3. Okay, let's go on to our next example. So now we are going to be working with a little bit more quadratics when the a value is not 1. So now we're going back to those factoring methods. Okay, so the first thing, we notice that it's already set equal to 0, so we're good to go. We need to see if these three terms have anything in common. If I look, they do not. So now when we do this, we are going to create our 2 sets of parentheses like we've done before. But instead of just putting x and x, what we have to do is not only we need to find the numbers that multiply to 9, but we also have to list the numbers that multiply to 4. So for 4, we have 1 and 4, and 2 and 2. For 9, we have 1 and 9, and 3 and 3. So for both of them, we have multiple pairings in our list. So remember, when you have multiple pairings in your list, you go from the bottom and then work your way up. So for the 4, we're going to try 2 and 2. So I have 2x and 2x. And then for my 9, I'm going to try 3 and 3. So now we multiply the inner, so we do 3 times 2x, that gives me my 6x. And then 2x times 3 gives me 6x. We're trying to add to the middle, which is a 12x. Well, if 6 and 6, if I add both of these, I do get 12. So I'm going to put a positive because I know that my 6x's are positive. So that means these are my factors here, 2x plus 3. So now I set my factors equal to 0. So I have 2x plus 3 equal to 0, and the same thing on the other side, 2x plus 3 equal to 0. So since they are the same factors, that means we are going to get the same solutions. Okay. So the first thing is I'm going to subtract 3 from both sides. So now I get 2x equals negative 3. Now I'm going to divide both sides by 2. So my solutions, roots or zeros, is going to be x equals negative 3 halves. Or if you want to, you can write that as a decimal as well. That would be negative 1.5. Okay, let's go ahead. Let's do our next example. So notice here that we have our equation is not set equal to 0, so we need to do that first. There we go. So in order to do that, what I like to do is keep my x squared positive. So what I'm going to do is move basically the things that are on the left hand or right hand side and move them over to the left hand side. So I'm going to add x squared to both sides. Now on my other side I have an x squared, so I can combine them because they are like terms. And I'm going to subtract x from both sides. And I can combine that with my negative x because they are like terms. So now I have 3x squared minus 5x minus 8 equal to 0. Okay, our next thing is to see if these three terms have anything in common. They do not. So now we are going to factor. So what I would like you to do is go ahead and pause this video and factor 3x squared minus 5x minus 8. Okay, let's see if you got the same thing as I. Notice that we do have a value that is not equal to 1. So what we have to do is find the numbers that multiplied to both 3 and to 8. For 3, we only have one pair, 1 and 3, so we'll have to use that. 8, we have 1 and 8, and then 2 and 4. Okay, so we know we have to do 1 and 3, so I definitely have to have x and 3x. So if I multiply x and 3x, I know that gives me 3x squared. So now we're going to work from the bottom and work our way up. So we're going to try 2 and 4 to see if that works. So I do 2 times 3x, that gives me 6x. And then x times 4, that gives me 4x. Well, if I added or subtracted these, there's no way I can get my middle term of 5x. So that does not work. Okay, now let's switch our 4 and 2. So I'm going to have x and 4. And 3x and 2. Remember, you always have to try each combination to see if it works. So I do 4 times 3, that gives me 12. And x times 2, that gives me 2x. Well, if I added or subtracted 12x and 2x, that would never ever get me to the negative 5x. So this doesn't work as well. Okay, so that means 2 times 4 does not work. So now what we'll have to do is we're going to do 1 and 8. Okay. Scroll down so I have some more room here. So I'm going to have my x, and I'm going to try 1, and then I'll have 3x and 8. So I do 1 times 3x, that gives me 3x, and then x times 8, that gives me 8x. If I added or subtracted, it is a possibility of getting a negative 5x. Now, in order to get a negative 5x, that means my bigger number, the 8, has to be negative. If I do negative 8x plus 3x, that does give me negative 5x. That means I need to have a subtraction here, addition in front of the 1. And if I do 1 times negative 8, that does give me negative 8. So this works here. So now I'm going to set my factors equal to 0. So x plus 1 and my 3x minus 8. And I'm going to go ahead and solve. So on the first one, I subtract 1 on both sides, so I get x equals negative 1. On here, I need to add 8. So I get 3x equals 8. And then I divide both sides by 3, so I get x equals 8/3. And leave your answer as a fraction. Do not change it to a decimal. So basically, if you get a fraction in which the decimal repeats or never ends, keep your answer as a fraction. So I get x equals 8/3. And x equals negative 1. Okay, let's go ahead and try our next one. What I would like you guys to do is go ahead and pause the video and try to complete this problem. So that means set it equal to 0, factor, and solve. So go ahead and pause the video to do example number 10. Okay, let's go ahead and go over this one. So notice we do need to set this one equal to 0. And so to do that, once again, always keep whatever your x squared is positive. So I'm going to move the 4x and negative 5 to the other side. I'm going to subtract 4x from both sides. And I'm going to subtract it with the negative 16x because they are like terms. And I'm going to add 5 to both sides and add it with the 15 because 15 and 5 are like terms. So now I have 5x squared minus 20x plus 20 equals 0. So now that I've set it equal to 0, our next step is to see if these three terms have anything in common. They do. They have a 5, which that is going to be your greatest common factor. They don't have a variable, so all I do is take out a 5. So I'm left with x squared minus 4x plus 4. So now notice my a value is 1. So what I can automatically do is create my two sets of parentheses here. I have x and x. Now for my 4, let's see numbers that multiply to 4. We got 1 and 4 and 2 and 2. Well, the ones that's going to add up to a negative 4 is going to be my 2 and 2. And both of them will have to be negative in order to do that. So now I set my factors. Now remember, this 5 does not have a variable. So if I do 5 equals 0, that is a false statement. So we're not going to set our 5 equal to 0, only the x minus 2. So those are going to be our factors that we're going to set equal to 0. type that out. So we have, and I'm going to put it over here. So we have x minus 2 equal to 0 and x minus 2 equal to 0. And notice that they are the same factors, so that means our solutions are going to be the same. So I get x equals 2 and x equals 2. So those are our solutions. Our roots are zeros. So x equals 2, x equals 2. Okay, we only have one more example left. Once again, I'm going to have you guys do the same thing. I would like you to go ahead and try example 11 all on your own. So meaning I want you guys to set it equal to 0, factor it, and solve. So go ahead and pause the video to do example 11. Okay, let's go ahead and go over this. So our first thing we notice is that it's not set equal to 0, so we need to do that. So once again, anytime we have a variable squared, we always want to keep that positive. So what I'm going to do is I'm going to subtract 63 from both sides. Now I cannot combine it with anything because there is no like terms. So I can't combine it with the 3x or the 6x squared because 63 are not like terms there. So that means I have my 6x squared minus 3x minus 63. Rewrite that. There we go. Now our next step is to see if these three terms have anything in common. They do. They have a number in common. The number they do have in common is a 3, so I'm going to go ahead and take that out. So I know if I do 6x squared divided by 3, I just get a 2x squared. If I do negative 3x divided by 3, that gives me a negative x or a negative 1x. And then negative 63 divided by 3, that's going to give me negative 21. Now notice that my a value is not equal to 1, so I need to find the numbers that multiply to it. So I have 1 and 2. Those are really the only numbers that multiply to 2. For 21, I have 1 and 21, and 3 and 7. I'm going to go ahead and create my two sets of parentheses. My 3 still stays out there until I actually solve. Okay, so I know since 1 and 2, that's the only pair, I have to use it. So I'm going to have x, or you could do 1x. And a 2x, and I know that works because x times 2x gives me 2x squared. Now I have to see which pair works to add up to our middle term of negative 1x. Let's try 3 and 7. So I'm going to do 3 times 2x, that gives me 6x. And x times 7, that gives me 7x. Okay, now if I added or subtracted, I am able to get a negative x. In order to get a negative 1x, my 7 needs to be negative. So I would do 6x minus 7x, that gives me that. Meaning I have 2x minus 7 and x plus 3. Let's make sure that we still get a negative 21. So if I do 3 times negative 7, that does give me negative 21. So this factorization works. So now I'm going to set my factors equal to 0. Now notice my 3, there is no variable attached to it. So if I do 3 equals 0, that doesn't make sense. So basically we're just going to set our x plus 3 and our 2x minus 7 equal to 0 to solve. So I have x plus 3 equal to 0 and then 2x minus 7. So on the first one, I subtract 3, so I get x equals negative 3. On the other one, I add 7 to both sides, so I get 2x equals 7. And then divide both sides by 2, so I get x equals 7/2, or 3.5. So my two solutions, zeros or roots, are going to be x equals -3 and x equals 7/2. Okay, make sure you do your homework over this. If you have any questions, make sure you contact me. I'll see you guys later. Bye.